Hey guys, okay, so I want to go over this worksheet with you guys that Karen has given to you guys in your class. I know we haven't talked too much about math here recently, at least I haven't with you since it's been a while since class. But also, some of these questions might be a little bit confusing because some of them are kind of the reverse of what we did in class. What I mean by that, the first example is exactly what I mean. The first one right up here that says we've been told that we need to infuse 63 milliliters per hour. Your patient is 105 kilograms. Here's how that particular medication is supplied. So 50 milligrams per 250 milliliters. So how many micrograms per kilogram per minute is your patient receiving? So I'm going to go back to that worksheet because a lot of those we can actually treat the exact same way. So this one is actually the same as the one we just did. You're given 45 milliliters per hour. So you would, look at that as 45 milliliters per hour. And then do the same thing. You'd multiply by the fact that it comes as 50 milligrams per 250. So 50 milligrams per 250 milliliters. And again, that's going to cancel out that unit milliliters. And then you can multiply by the 1 hour, 1 hour, run out of space here, over 60 minutes to cancel out that hour unit. And you'll do the same thing. Multiply straight across. That's going to end up giving you milligrams per minute. And then you can just convert that to micrograms and then divide by the weight. So the patient weighs, I think what they meant here is 165 pounds. So 165 pound sign, I think is what is supposed to be interpreted as 165 pounds. So don't forget, when you're converting pounds to ounces, pounds to kilograms, you have to take 165 divided by 2.2. So that weight would be 75 kilograms. So just as kind of a heads up on that. Looks like same thing on the second one. So number 2, you could do the same thing. Your patient, and this one's going to be much shorter. Your patient, because it doesn't have any micrograms, you have to convert, or you're not looking at it per kilogram. 9.5 milliliters per hour. Again, you want to know what that is in units per hour. So you could just say, okay, well, multiplying that by the fact that it comes as 25,000 units, and I'll write a little U right there, per 250 milliliters. When your unit milliliters cancels out, that shows that you're going to be left with units per hour. So you do the same thing, 9.5 times 25,000. Take that answer and divide by the bottom, 250, and that will give you your units per hour. So let's see. Okay, number 4, that fourth one, is kind of what we already know. It was given to you as units, and now you're trying to get it to milliliters. So this one's almost like doing just a D over H times Q formula, because you take the fact that you're getting 12 units per hour. I'm just going to put, I know that's not the right abbreviation for units, but just for space purposes. So you're ordered 12 units. It comes as a package of 100 units per 250 milliliters. So there's D, H, and Q. Remember, D and H just have to be the same unit so they can cancel out. Really, same idea as what dimensional analysis does, is as long as they're opposite numerator denominator, they cancel one another out. You would get the same answer had you have taken 12 units per hour and multiplied that by the known, so that there is 100 units. Oh, whoops, I need to reverse that. And I reverse it because, remember, I want to cancel out. So I'm multiplying this by how it's packaged. In a 250 milliliter bag, there are 100 units, and I put that, I flip-flop that because I want the units to cancel out to leave me with milliliters per hour. So that's the idea of that dimensional analysis there. Okay. Let's see. This one, the next one, is very similar to what we've, that very first example I gave you guys. This is what we did in class, where if I'm given micrograms per kilogram per minute, then I can go ahead and, just step by step, I'm gonna first multiply by the weight. So 252 pounds divided by 2.2 is 114.5 kilograms. So I'm gonna multiply by 114.5. I'm gonna take that and then multiply by 60 because I want to know what it is in hours, not in minutes, and then convert that to milligrams, because right now it's currently in micrograms. Convert that to milligrams, so that I can put it into the D over H times Q formula. So that's how we looked at that. But then again, you can always use that the dimensional analysis if that's easier for you. So it's very similar to those ones that we've been doing so far. This one is the same. It looks like you've been ordered the 6 micrograms per kilogram per minute. And it's just 2-step here. Wants to know what that is in micrograms per minute. So that means all you're going to do is first multiply by the weight. So what you would do is just take 6 times 75, because there's your weight. 6 times 75 would be 450. So there's your answer to that. It would just be 450 micrograms per minute. And the next step is to keep going to get it down into milliliters per hour. So then the next step would be to take that times 60 to get, when you multiply that by 60, you get 27,000. And what that is micrograms now per hour. We need to get it to milliliters per hour. So 27,000 micrograms is 27 milligrams. Putting that into the dosage formula, here's the H and the Q, 500 micrograms per 250 milliliters, so 27 divided by 500, and then taking that and multiplying by 250 would mean that this person is getting this IV at a rate of 13.5 milliliters per hour. And then on that very last one, it says the patient weighing 160 pounds is to receive a titrated infusion of medication between 5 to 10 micrograms per kilogram per minute. Again, here's the supply. So it first wants to know what is the dose range in micrograms per minute. So the only difference between the one that we just looked at, I should say, the one that we just looked at and the one that we are getting ready to do here is that we'll have 2 answers. For 1, for 2, and then there's a different one for number 3. So let me actually walk through this one. So patient weighing 160 pounds. So remember 160 pounds. 160 divided by 2.2 is 72.7. I think in peds sometimes they're a little particular. It says 72.72727272. Sometimes they want you to use that whole thing, and then you just round it when you get to the end. You guys may be taught that in peds. But just as kind of an FYI, and just for, again, just rounding purposes right now, I'm going to go ahead and round it. But your instructor may correct you later and say that we want to be as precise as possible. So I think I had a nurse tell me that one time, and she said that was kind of what you wanted to do. So let me go to a new screen. Package was 100 milligrams in just micrograms per minute. Look at that. What is the manual infusion rate in drops per minute? So drops per minute, we need to do a couple things. We're going to have to take every step that we did for this previous problem, because we want to get it into milliliters per hour first, and I'll explain that once we see that, because our drops per minute formula, the last question on that worksheet says the client stabilizes at 16 milliliters per hour. So what is that stabilizing dose then in terms of micrograms per minute? So all you have to do, and that's going to be incorporating how it's packaged again, which is 100 milligrams in 40 milliliters per hour. Micrograms per minute. Grams or 100 milligrams. And I'll go back to that to see what that, if I need to reference it. So it's 5 to 10 micrograms per kilogram per minute. Our patient was 72.7 kilograms, and then milliliters. Okay, 100 milligrams in 40 milliliters. Okay, so the first question just said, what is your range? So remember, that's just incorporating the weight. So what we have to do is just take that weight and multiply it by each side of the range. So the 72.7 we'll multiply by both 5 and 10. So again, some people will tell you to use the whole thing, the 72.72.7 or 7 not point 72.72727272. If I did do that, but you would get 72 point let's see, times 5 is 363.63635. If I just rounded it, 72.7 times 5, you get 363.5. So, again, you may want to be as precise as possible, but that's, again, something you might want to ask your instructor. So I'm just going to use the 72.7 and say that, again, that is now 363.5. And again, all we're doing is eliminating this part by multiplying the weight. So that's micrograms per minute. When I multiply that by 10, then that's 727 micrograms per minute. So there's your range, 363.5 to 727 micrograms per minute. So now we're going to take this a little bit further. And so the next step says that remember our drops per minute formula is volume divided by time multiplied by the drop factor. And the drop factor is given to us in the problem. But in order for us to divide volume divided by time, volume needs to be in milliliters and our time needs to be in minutes. So we're going to have to get this down as far as we can. So let's say this. Okay, so right now it's in micrograms per minute. So what we can do, we need to get it into milliliters. Right now we don't have to even think about multiplying it by 60 because the question is wanting us to leave it in minutes. So I'm going to go ahead and take both of those numbers, and I am simply going to put those both into the dosage calculation based on, again, how it's packaged. But don't forget, in order for us to match, I want it to be in milligrams, or at least they both have to be the same unit to put it into the D over H times Q formula. So for the first one, I'm going to use 0.3635. Again, I've just moved my decimal 3 places to the left to get it into milligrams. So that's milligrams over 100 milligrams per 40 milliliters. And then do the same thing with the other one, 0.727 milligrams over 100 milligrams per 40 milliliters. So doing that, what that will calculate now, because my milligrams are going to cancel out, that's going to give me milliliters per minute. I've left it in minutes, remember. So right now it's going to get it into milliliters per minute. And I'll show you the purpose of that. So 0.3635 divided by 100, and then multiplying that by 40 is going to give me, and I'll write these in green, 0.1454. And right now that's milliliters every minute. And then doing that to the next one, 0.727 divided by 100, taking that and multiplying it by 40 is now 0.2908 milliliters per minute. Okay. So far, there's what we've done. Now on the next page, I'm gonna actually just write out what we have as our answers, but I want to give some room down here. So 0.14. Remember, 0.2908. Here, I'll tell you what, let me add another per minute. Sorry, I have to keep going 30 minutes here. So if they stabilize at 16 milliliters per hour, I want to know what that is in micrograms. Is that what it was? The sheet here. So I want to know what that is in terms of micrograms per minute. So like we've done before, what that means is, okay, well, since there, is, oh man, I already forgot. I think it was there somewhere. So since there are 100 milligrams in 40 milliliters, I'm multiplying that by that package to see how milliliters would cancel out. And then you can multiply by the fact that there's 1 hour and 60 minutes, using that dimensional analysis here, so that hours will cancel out. Now I'm left with milligrams per minute. So 16 times 100 up there at the top is 1600. Down at the bottom, 40 times 60 is 2400. Yeah, it's not a unit. So then taking that 1600 divided by 2400, I'll make sure I'm doing that right. Yeah, gives me 0.6 repeating. I can go on forever, but again, that is in milligrams per minute. I need to know what it is in micrograms. So milligrams to micrograms is 3 movements to the right. So just rounding that off would be 666.7 micrograms per minute is what they've stabilized at. Okay, 0.1454 is what we have right now in terms of milliliters per minute. Now remember, our dosage calculation says, our drops per minute formula is what we're trying to calculate. And like I said, that's volume over time multiplied by the drop factor, which was given to us in this problem as 60. So just FYI on that. So all we have to do, since it's 0.1454 milliliters per minute, that's the same thing as per 1 minute. So there's my volume and my time. I just need to take that and multiply it by 60. So 0.1454 times 60 means that first range, or that first number in our range, is 8.7 drops. Oh wait, but drops are rounded to the nearest whole number, so it's 8.724. So that's about 8 drops per minute. The second one was, again, remember that one was 0.2908 milliliters per 1 minute multiplied by my drop factor of 60. And that's what that's going to, again, what's happening is your drop factor is 60 drops per milliliter. That's what I mean by drop factor. That's the infusion rate. So remember, what's happening is the unit milliliters are canceling out, and that's why we're left with drops per minute. So again, you're still seeing that kind of drop, that canceling out situation taking place. But 0.2908 times 60 is 17.4, so that would be about 17 drops per minute. So in that second question, it was asking you for that range, and the answer would be 8 to 17 drops per minute is what we're looking at. And you can use a dose. End of class is the exact reverse of this. So what we did, just to give you guys an example, in class, I would give you that the patient has been told to take 2 micrograms per kilogram per minute. Okay, and I'm writing it this way because remember what we did is when we needed to then find out, what would they receive in milliliters per hour, because that particular medication that we've ordered comes in liquid form. It's something that needs to be infused in an IV. So there was a couple different things we had to do. We had to, one, in order for us to convert micrograms to milliliters, we used our dosage calculation, and that was the D divided by H times Q. We had to incorporate their weight, so we multiplied by whatever their weight was, and again, that would have been given to you in the problem. So say if this was, what was ordered, if I said that the patient is 105 kilograms, and I said that it was supplied as 50 milligrams per 250 milliliters. That's how it's packaged, so that's what's going to go into the D over H times Q formula. So I'm going to erase some of the stuff that we have over here. Okay, so going back to our little step-by-step here, in order to convert micrograms to milliliters, so to get it from, that order dose to the milliliter form, we had to incorporate that. We had to put it into a dosage calculation. Whereas to then incorporate the weight, we just multiplied it by the weight, and then to get minutes to hours, we multiplied by 60. And I told you guys in class that it doesn't necessarily matter what order you go in as long as you're doing each of these steps. So what we did in class is we said, okay, if they need 2 micrograms per each kilogram, so 2 micrograms per every kilogram, well, for a patient who weighs 105 kilograms, that's going to be 105 times that dosage. So I multiplied that by 105. And 105 times 2 gives me 210. So what that has just calculated, so 105 times 2 is 210. So that means this person needs 210 micrograms every minute. And again, just what we've done in that original ordered dose is I've eliminated the kilogram part, and it's just now micrograms a minute. So what we have left up there. So then we said, okay, well, if that's what they're getting per minute, well then in an hour, they're going to do that 60 times, 210 micrograms every single minute. Well, that would double after 2 minutes. It would triple after 3. So what we did is we just said, okay, well, we'll multiply by 60 to see what they're getting in an hour. So that came out to be 12,600 micrograms every hour. Hour. And then what we did is we said, okay, well, now we've got it into this form. We've got it down to just per hour. So the idea is we want to find then what that would be in milliliters, and that would be a matter of plugging that into the dosage calculation. So I'm going to do this in this blank space over here. So what we did is we would say that, okay, well, if we plug that into the dosage formula, since the medication is packaged this way, there's my H and my Q. Since H is in milligrams, I also have to have that order dose in milligrams. Right now, it's in micrograms. So remember, we move our decimal 3 places to the left, or divide by 1,000, and that would mean that they need 12.6 milligrams every hour. Well, then to see what that would be in milliliters, we took that divided by how it's packaged, 50 milligrams per 250 milliliters. And when I calculate that, we would see that 12.6 divided by 50 is 0.252, and then take that and multiply by 250, we get 63. So that means this person would need 63 milliliters per hour. Oops. Which is, I know what your question is. And so you guys are thinking, okay, great. Now that I've seen it the way that we did it in class, how do I do it backwards? So there's 2 ways that you could do it, as far as what that question is asking you. And I know that Karen teaches you guys dimensional analysis. I know we didn't go over too much with dimensional analysis because we didn't have a whole lot of time. But I'll show you guys what that entails, and it's actually not too bad. Because you could do it, if you remember what we did in class, what I just showed you guys, and all those different steps, you could do that, and you could do the reverse of that. And that would mean that if given 63 milliliters per hour, then, okay, let's reverse that. I know that that's what they're going to end up taking. So what that means is D over H times Q is equal to 63, this. So you could do it that way. You could say, okay, well then I know what H and Q is, because that's, remember, how the medication is packaged. That's the 50 milligrams per 250 milliliters. So you could say, okay, well, X over 50 times 250 then is equal to 63. Again, I'm just going backwards from what we just did. And so, just like we know how to solve for X, I'm going to divide both sides by 250, because remember, I'm doing the opposite of what's being done first. If I did that, 63 divided by 250 is, again, it's just, hopefully this is familiar because only because we just saw it. And that would cancel that out, and that would leave me with X over 50 is equal to 0.252. And then I'll multiply both sides by 50. Oops, writing that out. Multiply both sides by 50 to solve for X. So doing so would tell me that X is equal to 12.6. And what we just figured out is, again, remember, because H is in milligrams, that means whatever this is also in milligrams. So we just found out that the ordered dose is 2.6 milligrams. So now we just need to do the opposite of what we just, again, what we know. We're trying to get it to micrograms per kilogram per minute. And so again, you could go ahead and convert those milligrams into micrograms by moving that decimal 3 places to the right. That would mean that this is the same thing as 12,600 micrograms. I need to know what that is, again, per kilogram per minute. So now your next 2 steps would be the opposite of what we just did on the previous, what we were taught in class, and that would be to divide by 60, because again, there's 60 minutes in an hour, so you could divide by 60, and then you're going to divide by the 105, the patient's weight. Again, just because it's the opposite of what we just did, and the order doesn't matter. You could do either one first. If I decided to go ahead and divide this by 105, just because I'm going in the exact reverse order, or no, I'm not going in the exact reverse order, but I'm going to just choose to do that one first. 12,600 divided by 105. Whoops, I didn't type that in correctly. 12,600 divided by 105 is equal to 120. So that means this person is getting 120 micrograms per kilogram right now. Again, that's by dividing that by kilograms. That's what we're seeing is micrograms per kilogram is what we just tallied up. But then dividing that by 60. So again, it's almost like you're looking at it this way. Oh, that is not what I meant to do. Sorry. I'm going to draw this up here at the top. 12,600 divided by 105, then divided by 60 is exactly what we're getting ready to do. Remember, your 12,600 is in your micrograms. 105 is that patient's weight, and 60 is the minutes. And look what we would calculate, because nothing cancels out. So look what we would calculate when we do that. So now taking my 120 and dividing that by 60, we know that that is then 2. So your answer to that first question is definitely 2. So you could do it that way, and I know that's kind of all over the place, but it's just, I'm just kind of solving each step along the way. What Karen shows you guys is the dimensional analysis. Dimensional analysis is great because it just kind of shows you, based on what you have, how units can cancel out. So if you have 63 milliliters per hour, you can multiply this by either 1 hour, 60 minutes, or by how the medication is packaged. Again, the order doesn't really matter. But if you said, what I mean by how the medication is packaged, again, remember that there are 50 milligrams per every 250 milliliters. What that does, that's going to cancel out this unit milliliter, and that's going to then leave me with milligrams per hour. So the only units that I'm left with. So you could go ahead and calculate that step, or you can go ahead and just make this one whole problem. The next part to that would be, what we know about minutes and hours. Well, and you want to put 1 hour on top and 60 minutes. It's just looking at it as a known. What that does is that's going to cancel out the unit hours, and that's going to leave me, when I multiply straight across, the only 2 units I'm left with now are milligrams per minute. So, again, we're used to converting milligrams and micrograms and things a little bit differently. So Karen probably shows you that there are 1,000 micrograms in every 1 milligram. And you could go ahead and do that way if you wanted to. Or you could go ahead and kind of do what we just did and how we're used to, converting metrics. You could go ahead and multiply everything at the top. So that's 63 times 50. And that will give you 3,105. 3,150, not and 5. Then multiply down at the bottom, 250 times 60 is 15,000. And if I went ahead and divided this right now, 3,150 divided by 15,000, it's going to give me a decimal. It's going to give me 0.21. What I've just calculated, again, is milligrams per minute. Milligrams per minute. I, again, want micrograms per minute. So because we know how to convert using just moving the decimal, you're welcome to just go ahead and do that now. Milligram to microgram, I know, is 3 places to the right, so that would make this 210 micrograms per minute. So that minute's still there. And then to look at that as, again, now per kilogram, all you have to do is just divide by that weight. So that's kind of what we're doing as that per kilogram. Look at that as division. So 210 divided by 105 is going to give you 2. 210 divided by 105 is 2 micrograms per kilogram per minute. I know right here I have it a little out of order, micrograms per minute per kilogram. It means the same thing. So that's how you can incorporate the dimensional analysis. I honestly think that dimensional analysis kind of makes that, in my opinion, a little bit easier. It's less all over the place. And I wish I had a chance to show you guys that in the math class. And anytime you need any help with that, if you are super confused on how she's showing you guys this, you're welcome to just, again, shoot me an email and I'd be glad to show you different examples using that. Or let me, worksheet. And that one, I think, worksheets that she gave you was kind of the more complicated one. There was also this worksheet that she gave you the key to, that I was looking through, and it looks like she's just using the dimensional analysis. But I think for the most part, most of these you could, if you wanted to, just use the dosage calculation formula, because again, it's the exact same thing. So like on the first one, number 1, it says your patient is ordered whatever that medicine is, 400 milligrams by mouth every 6 hours. The medication is constituted as 300 milligrams per 10 milliliters. So how many milliliters would you administer? Again, she uses the dimensional analysis, so the milligrams cancels out, giving you, again, just milliliters. But we looked at that, again, using D over H times Q. You very well could get the same thing if you put the ordered dose divided by the dose on hand, multiplied by the quantity on hand. 400 divided by 300 times 10 is also 13.3. So you would get the exact same thing. Same thing, let's see. Number 2, that's knowing, when you're trying to calculate milliliters per hour, our flow rate formula said to just take your volume and divide it by the time. Remember, we did that in class. If we're trying to calculate milliliters per hour, that's what we do. So administering 200 milligrams diluted into 100 milliliters. This is extra information, that 200 milligrams. All we need is the total volume there, that 100 milliliters. So volume divided by time, 90 minutes, again, since that's in minutes, you really want it to be in hours. So how you could do that, 90 divided by 60 is an hour and a half. So you would just use 1.5 instead. If you used 100 milliliters as your volume divided by 1.5 hours as your time, you would also get 67 milliliters per hour. You get the same thing. And that's how I had taught it to you, was looking at that formula for those IVs. Let's see, number 3 is another, you can use D over H times Q. So just looking at D, and then there's H and Q. So 0.2 divided by 0.4 times 2 would also give you 1. 0.2 divided by 0.4 is 0.5 times 2 would also be 1. Same thing with number 4. This is your ordered dose, 2,000. The solution is available in 10 milliliters with a concentration of 1,000 milliliters per hour, or 1,000 units per milliliter, I'm sorry. They threw in some extra information for us that we didn't need to know that it was available in a 10 milliliter bottle. We just need D, H, and Q. I need the ordered dose, D, divided by H. It comes 1,000 units per 1 milliliter. So there's D, H, and Q there. Our time formula for the number 5, when I taught you guys this, I told you guys to remember the formula. Time is equal to volume divided by flow rate, which is milliliters per hour. So that's, how we looked at it. But again, just like dimensional analysis, what happens is the unit milliliters cancels out when we do it that way. So on that one, you could take that total volume. It says doctor orders 1,000 milliliters. So you could just take 1,000 milliliters to run at 75 milliliters per hour. So 75 milliliters per hour. And that will tell you if you take 1,000 divided by 75, you should get the same thing. And you do. You get 13.3. And then she's showing you how you convert that. So that's about 13 hours. If you want to get it into hours and minutes, I think I remember showing you guys this in class, that when you get a decimal, you could take that number that's after the decimal point, so that 0.3. And if you just took that 0.3 and multiplied it by 60, it gives you 18. So that means that would be about 18 minutes. That we did that because, remember, decimals are based on units of 10, 100, 1,000. Remember, our place values, tens, hundreds, thousands. So that 0.3 doesn't really equate to minutes. The same way, like, if the answer was 13.5, that's 13 and a half, which in terms of hours and minutes would be 13 hours and 30 minutes. So how you can get that decimal and look at that in terms of minutes, just simply multiply that by 60. So again, 0.3 times 60 gave us 18, so that's about 13 hours and 18 minutes. And I think that may be what's happening over here. I'm not really sure. Okay. Okay, same thing. I'm just going to the next couple pages. This one's calculating milliliters per hour. Again, she's using that dimensional analysis. If the insulin drip is ordered at 8 units per hour and it's mixed 1 liter with 1,000 units of insulin, then that just simply means, gosh, that's just 8 units. Oh, I see. Because our D over H times Q, 8 units is what's been ordered, it comes packaged as 1,000 units per 1 liter. So if we did 8 divided by 1,000 right now, that would tell me what the answer would be in liters. So you could just go ahead and convert that to milliliters if you wanted to, and 8 divided by 1,000 times 1,000 would just be 8. Even if you didn't do that, if you did do 8 divided by 1,000, 8 divided by 1,000 is going to be 0.008 in liters. But remember, liters to milliliters is moving your decimal 3 places to the right, so that would convert it to 8 still. So you could still do the same thing. You're still seeing D over H times Q is what's happening on that still. Let's see. Same idea. Calculating milliliters per hour is just volume divided by time. It looks like that one may have given us some extra information. Let me read that. Patient is 250 milligrams and 50 milliliters ordered every 6 hours. Okay, medication is to be infused over 30 minutes. Yeah, extra information on here. It's when we're calculating milliliters per hour, that's all we need is the milliliters and the hours to see, okay, how much volume is to be given over a certain amount of time. Well, so again, if we're just taking, I'll write this over here, all we're looking for is milliliters divided by hours, so our volume divided by our time. So what that would look like then, this is extra. That's just telling us that 250 milligrams is how much medication is in there. But we know the total fluid volume is 50 milliliters. That's the total volume of that liquid. To be given over, I keep saying over. That's what we're looking for, is over. When it says to be given every 6 hours, that's the number of increments we're given that. So we're giving that, right now, and then once again in 6 hours. So that's not over that certain amount of time. It's to be given over 30 minutes. So that's what's important here. From this problem, we only need the 50 and the 30. So again, 30 minutes is half an hour. So if you just took 50 milliliters divided by 0.5 hours, you would get 100 milliliters per hour. So we looked at that in class. That was the way that we looked at those types of problems. And then same thing, milliliters per hour on the next one. 1,000 divided by 2 is how we would get milliliters per hour on that one. Okay, and then number 9. It actually looks like number 9 has a misprint in it. What I mean by that is it says, here's what's been ordered, and then it says available 10 milligrams per kilogram. So it says the exact same thing. I think what they meant on the 10 right there is milligrams per milliliter. It looks like that's what she even corrected it right there in what she was doing. The way we did this in class is we still continue to use the D over H times Q formula. And these that say milligrams per kilogram, we just are specifically figuring out what our patient's order dose is. We already know, and I'll write it over here, we already know H and Q. We know H is 10 milligrams per 1 milliliter. Again, that's a typo. It's supposed to be per milliliter. But since it says 15 milligrams per each kilogram, what you had to do is figure out first what the patient weighs in kilograms, and so that's what was happening here. 96 divided by 2.2 is 43.63. And then specifically trying to figure out what our patient needs, you just multiply that by the dosage to get what our patient needs. So that just gets plugged into our dosage formula. and you know, if you round it, I would guess maybe she wants you to be more specific, so you can use the 0.45 or 545. If you do that, then it's just a matter of taking that divided by 10 times 1 in the dosage formula, and you'll still get 65.5. So that's how we did that. It's still using the D over H times Q formula. Same thing here. This was 120 divided by 40 times 1 is how you could do that. D over H times Q. Same thing here. 30 milligrams is what's been ordered. It comes as 60 milligrams per 1 tablet. So there's D over H times Q. And you still get over on number 12, let's see. Receiving an insulin drip at 7 milliliters per hour. It reads 1,000 units. Oh, okay. So how many units? So this is, again, kind of the reverse of the D over H times Q. So she used the dimensional analysis formula. So you could just say, okay, well, if I have 7 milliliters per hour, I want to know what they're getting in terms of units per hour, where that, well, that comes as 1,000 units. It's a UN, I'll just abbreviate that, units per 250 milliliters. And so that allows us to cancel out that unit milliliter, and so then we're left with units. Well, I can't circle that, units per hour if we did it that way. So that's what she's doing in that dimensional analysis formula. You could always, again, as we've talked about on the previous page, you could always do the reverse of our D over H times Q if you're more comfortable with that. We know D over H times Q, well, if whatever that ordered dose is, and then here's how it comes, 1,000 units per 250 milliliters is equal to 7 milliliters, then you can just do the reverse. Divide both sides by 250 and then multiply both sides by 1,000 and you'll still get the same answer. So it's just, again, to each his own, whichever you're more comfortable with. Don't forget in number 13, our formula for drip rate, like we've seen before, volume over time multiplied by our drop factor. Volume needs to be in milliliters and our time needs to be in minutes. So once again, giving us some extra information that there's 1 gram in 100 milliliters. So all we need is the 100 milliliters. That 1 gram is just how much medication is in that volume. So I would just use the 100 milliliters. Let's see, every 24 hours. Remember, that's every 24 hours, so that's the amount of increments, but it's to be administered over 1 hour. So that's the important part from that right there, is that it's how it's given over that course of time. So our time in this case is actually going to be 60 minutes. Don't forget we're calculating drops per minute, so it needs to be in minutes, and then we multiply by our drop factor of 15. So 100 divided by 60 times 15 should give you the same thing, times 15. Yep, is an even 25. And then number 14, volume over time, but it's flow rate, so you're trying to, oh no, wait, the rate of, oh, I'm sorry. This one is trying to figure out how many, just get all that out of the way, how much fluid is to be administered. So on this one, our volume formula said to take our time and multiply it by our flow rate, that milliliters per hour, because again, what happens when you do that, if our time is in hours and our flow rate is milliliters per hour, then our hours can cancel out and leave us with milliliters. So we just took our time and multiplied it by the flow rate, and that's exactly what she did on that calculation too. So it looks like for the most part, all of these are kind of set up the same. 15, I might as well go ahead and keep going here. 10 milligrams per kilogram. Okay, so that one is just if your patient weighs 212 pounds, they need, there's that weight. That question is just asking us how many milligrams would your patient receive. Well, if it's 10 milligrams per kilogram, it would just be 10 times the kilogram weight of 96.4. That's how many milligrams they're going to get. We don't have to put that into a dosage formula or anything because it didn't tell us, how it's packaged and, what we need to administer or anything like that. And number 16, an IV medication with a volume of 100 milliliters to infuse over 30 minutes. Set the calibration. So what's the drops per minute flow rate? Easy. 100 milliliters. There's our volume divided by our time. It's already in minutes for us, multiplied by our drip rate. So it'd just be 100 divided by 30 times 20, and it would give us 67. And the very last one there, so 60 milliequivalents is ordered for your patient. Micro K is available in 20 milliequivalent tabs. So, yep, D over H times Q would just be 60 divided by 30, since they're both, or I'm sorry, that's 20. It's supposed to be 20. Since they're both the same unit, doesn't matter. I know we're not quite used to seeing milliequivalents very often. It's kind of similar to milligrams, but as long as they're the same, they'll cancel out, and that's all that matters. So they're available in 20 milliequivalent tabs, so that's 20 per one tab, so our quantity would just be 1. So 60 divided by 20 is 3. So that's what we got on that one. I think sheet. That was it on that. Oh, no, I'm sorry. There were 2 more. Or, yeah, 3 more here, sorry. So I just want to make sure that they're all the same. Use a label to prepare a dose of, okay, so what's been ordered is 350 micrograms, but it looks like according to the label it's packaged as milligrams. So remember, in D over H times Q, D and H just need to be the same unit. So I'm in the habit of getting everything into milligrams, so I converted those micrograms by moving the decimal 3 places to the left. That would make that 0.35 milligrams divided by that dosing on the package there, 0.4 milligrams per 1 milliliter. So it'd just be 0.35 divided by 0.4, and it gives you 0.875, and that's just rounded to the 10th there. Using the label for the Thorazine there, order dose is 40 milligrams, and it looks like the package is 25 milligrams per milliliter. So yep, D over H times Q, and they're already the same. Divided by 25 per milliliter, so it'd just be 40 divided by 25. And it looks like, yep, same thing with that last one. 75 milligrams is what's been ordered. It comes as 50 milligrams per 1 milliliter. I know that's hard to see, but it's right there. You see that dosing right there. And so that's how that would be administered. Pretty much the majority of that. But that was because it was a mix of things she gave you. It looks like it's more drops. So it's more of, to keep in mind when we're doing drops, that it's volume over time, but always remember volume must be in milliliters and our time must be in minutes. And then to calculate the drop factor, we're multiplying, or to calculate the whole drops per minute, you're multiplying by a drop factor, which is a milliliter per, no, it's a drops per milliliter infusion rate. Sorry, guys. I'll write that. So it's a drops per milliliter infusion rate. And so when you're multiplying by that drop factor, again, what happens is the units milliliter will cancel out and leave you with drops per minute, exactly what you want there. So you have to do that in each of those. So I don't want to do all of this homework assignment for you. I don't know if it's a homework assignment or just practice, but I need you guys to be able to do these as well. I just wanted to walk you guys through, and I ended up walking you guys through the problems, and it looks like these are all going to be calculate drops per minute. So as long as you are using this formula, then you should be good on those. But you guys know, if you ever have any questions, let me know. Thanks, guys.